Hello everyone, welcome back to Everything Swift. Today we'll be tackling Leetcode question 108 titled Convert Sorted Array into Binary Search Tree. So I did this question a year ago, around there, but that video doesn't have any explanation. It's just kind of like live coding. So I'm just redoing this video with some explanation. Hopefully that helps. So yeah, so this question essentially is pretty much stated in this question title itself. We are given an array of integer, and we are basically supposed to return a binary search tree, which is of type tree node class here, right? So binary search tree behavior is essentially the root is bigger than the left side and smaller than the right side, and it only has left and right, hence the name binary. So yeah, those are the important characteristic that we need to pay attention to. So basically, as we can see in this example here, we are given this array here, -10, -3, 0, 5, and 9, and it is represented in a binary search tree, as we can see in this diagram here, where 0, -3, 9, 5, and 10, right? So -3 and -10 will be on the left side of 0 because they are both smaller than uh, this node root node here, which is 0. So that's why it's on the left, and 9 will be on the right because it is bigger than the root node here of 0, and 5 will be on the left of 9 because this child node of this node is smaller than 9. Same goes for -10. It's on the left of -3 because it's smaller than -3, right? So the most important thing to understand of this question is basically the characteristic of the binary search tree. Right, so that's step one. So hopefully that explanation kind of like gives you the understanding to why it is set up as such. The second thing is like, how do we solve this problem, right? What's the strategy that we can solve here? So the key thing to note here is that this integer array is actually sorted in ascending order. So as we can see in the input array, it is -10, -3, 0, and 5, and 9, right? So it's in increasing order. So what we can do here, as you can see in this diagram, so 0 is sort of like the middle of the array here, as you can see here. That is the root node, right? And then everything towards the left is basically everything before the root node, and everything towards the right is basically the right side of the root node here. So essentially what we can try and use here is basically a binary search formula performed on top of this integer array here, and then we are going to recursively break it down throughout the entire array. So for example, this array here, the midpoint of this integer array is basically 0, so that forms the root node. After that, what we're going to do is we're going to have a recursion to actually build up the left component of the binary search tree, which is factoring from this starting point all the way to everything before the root node. So it's -10 and -3. Then on the right side is basically starting from everything towards the right all the way to the end of the array. And then imagine that we have more numbers towards the starting index and ending index, maybe like -20, -10, -3, and then 5, 9, and 20, for example. Essentially, the strategy doesn't change. We are going to perform binary search tree because it's also a sorted array. So we can actually break it down using the recursion. So the size of the array here doesn't change the strategy here. So that's basically the strategy that we're going to apply today. Yeah, so I'm just going to jump straight into the coding, and hopefully that gives you a better understanding of what I just said. So first thing first, I'm just going to check if the nums array is empty. If it is, I'm just going to return nil. Just for performance reason, I'm going to try and exit out of this function scope if the numbers array is empty. Essentially, because if it's empty, we can't work with anything, right? We can't build the binary search tree, so hence we just return nil. So as I mentioned, we're going to perform a recursion. So I'm just going to create a helper method here, and I'm just going to call it build. Basically, we are going to take in the source here, which is the integer array. So nums integer array. And as I mentioned, because our strategy is to use binary search, so the key component in binary search is basically to find the midpoint where we can derive it from the starting index and ending index. And then I'm just going to return 3 node here. And what we're going to do is basically call this function, right? So we're going to pass in the source, which is nums. The starting is basically the starting index of the array, so that's 0, and the end is basically the last index of the array, so nums.count minus 1. So just for safety check, I'm just gonna check if the start is bigger than end, which shouldn't be the case. I'm just gonna return new. And yeah, so right now in this recursion here, we're going to perform the binary search so that we can use that value as the uh, root node of the binary search tree. So I'm just going to count here, let mid start plus n minus start divided by 2, let mid value equals to nums of mid. And then here, what we're going to do is basically create the binary search tree. So let root node equals to 3 node and pass in the mid value here. And this is where the recursion comes in. So root node dot left equals to, we're going to call this particular function within itself. So build of nums, the source, and the starting point, because this is the left side. So we're going to start from basically the start of it, and then the ending is basically everything before the mid index, so mid minus 1. And then for the right side is basically root node dot right. We're going to call the same function to do the recursion here, and we're going to pass in the source, and then the starting is basically everything after the root node, right? So mid plus 1 all the way to the end of the array. So just call n, and that should be it. That is probably our solution. So return root node here, we already called it. Seems to be right. Let me just go ahead and run this. Hopefully we got it right. There we go. Answer looks good. Let's submit this. And there we have it. That is the solution. So yeah, just to recap, basically we're using two main ingredients here to kind of solve the problem. Basically a recursion and also binary search, right? The recursion is basically to build up the left and right node of the binary search tree, and then basically to figure out the specific root node, we are using the binary search formula. So as we can see here in using this example, the first one we will find the mid index, which is 0, and then we create the root node, which is 0 as the root, and then the left side is basically we are taking the starting, which is the 0 index, -10, all the way to mid minus 1, because the root is 0, so our range is basically -10 to -3. And then the right side we are going to do recursion as well, where we take the starting index is basically the mid plus 1, so root is basically the mid, so one index after it is our starting point, so 5 all the way to n, so 5 and 9. And that's basically it. That's how we build a binary search tree from a sorted array using recursion and binary search. So yeah, I hope this video is helpful enough for you guys to understand this question. If you guys feel this video is helpful, feel free to subscribe to this channel. I'm trying to grow this channel, and please feel free to share it with any Swift developer or iOS engineer. Yeah, so thank you very much for watching. Take care and bye bye.